soap particles clean the dirty. Soaps are one of the most commonly used cleansing agents and are capable for reacting water to remove dirt. Example for soap formula is sodium stearate is the chemical name C17H35COO minus Na plus. And one more formula for sodium lauryl sulfate, its formula is C12H25SO4Na. Its another name is sodium dodecyl sulfate SDS. So when soap dissolved in water, it forms anion surfactant. That anion surfactant only considered as here a colloid. So when soap molecule formula is C17H35COONA. This is C17H35COONA. So when it placed into the water, it forms C17H35COO minus. So this is the colloidal particle. Such kind of many colloidal particles will released into the water. So these colloidal particles is formed as a cluster, is a group of colloidal cluster. That group of colloidal particle only known as micelle. This colloidal particle have two terms. First end is hydrophilic end, it is negative or positively charged end. The another part is hydrophobic end. This hydrophobic end there is no charge. This is carbon chain. So two ends it have. One is hydrophilic end and another one is hydrophobic end. So these soap particles when ionized into the water to form a micelle. So micelle means what I told you, that is an associated colloid. It is a group of colloidal particles to form a micelle. Colloids act as strong electrolytes at low concentration. When you add a little soap, it acts as a strong electrolyte. When more quantity when you add it, it acting as a colloidal associated colloid. Colloids act as strong electrolyte at low concentration, but at high concentration they behaves as colloidal solutions due to the formation of aggregated particles, group of particles. The cluster of colloidal particles in liquid is known as micelle. Cluster of colloidal particle is this one. So in what way this cluster will be formed, that is known as formation of micelle. See, this is the cluster of colloidal particle. One particle, 2, 3, 4, 5, 6, 7 and 8. These all are the group of colloidal particles. This group of colloidal particle only termed as micelle or associated colloid. How it will form? When a dirt cloth is placed in a soap solution, the long non-polar hydrocarbon that is called as tail of soap molecules points towards the oily dirt. Here inside we have an oily dirt. This is an oily dirt particle. So the all tail molecules of organic compound, that is sodium stearate, this will be attacks this dirt particle. When a dirt cloth is placed in a soap solution, the long non-polar hydrocarbon tail soap molecules pointed towards oily drop. This is tail and this is head. Oily dirt particles, and the polar heads point towards the water. So these polar heads attracts water molecule. With polar, this formation of spherical structure with polar part of the molecule on the surface and non-polar part is in the center. Non-polar part is in the center. Polar part minus, this is polar means negative part. Polar part towards the water, non-polar part towards the dirt. Non-polar parts in this center. This spherical structure is called micelle. Entire spherical structure is called micelle. Once again I am repeating, formation of micelle. When a dirt cloth is placed in a soap of solution, the long nonpolar hydrocarbon tail of soap molecules point towards of dirt particles and the polar heads point towards water. This form of spherical structure with polar parts of the molecule on the surface and non-polar parts in the center. This spherical structure is called micelle. Micelle in this way form when soap is placed into the water. Step 1. Step 2. Micelle around the oil droplet and dirt within a soap like this. This is the dirt particle on cloth, this striped checked cloth. So this is the dirt particle. All colloidal particles, micelle particles are attacking this dirt, non-polar carbon particles are attacking the dirt. The soap molecules are all these. So polar head pointing towards water and the non-polar tail pointing towards the dirt. So that is the reason I have given the title dirt within a soap molecule. This dirt within the soap molecule. All soap molecules are attacking this dirt. The micelle around the oil droplet. This micelle attacking around this oil droplet. This is the second step. Then micelle is attracted towards water and carries oily dirt. After that, this micelle is there. These are all heads. These are all heads attracting water molecules. This minus particle is attracting water molecule. So when this is attracting water molecule, micelle also coming towards water side. This is attracting water molecule. Micelle also coming towards water side. When you rub with your hand, when brush with your hand, or when you keep it in washing machine, this dirt will come out along with water. Water is attracting this. Water is attracting this molecule. Water is attracting this molecule. Like way, it is the entire this mole is coming for moves towards water side. So that is the third step. Micelle is attracted towards water and carries the oily dirt. Oily dirt is moving water side. See here, the oily dirt particle is there. While attracting water molecules, this heads, so it is moving towards outside along with washing. Then entire this cloth is going to be a clean. And third step, micelle is attracted towards water and carries the oily dirt. First micelle formed around the dirt and after that this hydrophilic ends, negatively charged ends attract towards water. While these are attracting towards water, these oily dirt also coming out. This oily dirt also will coming out like this. For example, this is taking some dirt, this molecule is taking some dirt, this is taking some dirt. Entire this way, whole dirt will be clean out. Third step, micelle is attracting towards water and carries the oily dirt. This micelle is attacked towards water and carries the oily dirt particle along within it. This causes the dirt particle to detach from the fiber of cloth. In this manner, cloth become free from dirt. Now the cloth is become free from dirt. The rubbing of clothes with brush or agitation in washing machine loosen the bond between dirt particle and fiber cloths. This supports the cleaning action of soap and detergent. By rubbing or brushing and washing machines are helping to move this micelle along with the dirt is coming out. This is about the cleaning action of soap. First soap molecules are formed. The soap molecules formed as a micelle. This micelle attacks around the dirt particle and after that the hydrophilic ends attract towards water. Hence, along with the dirt particle, these molecules are attract towards water. That's the reason this dirt particle is slightly moving on the surface of the cloth. Slightly moving after that while rubbing, and when you keep it in washing machine, entire the dirt will coming outside the surface of this cloth. This is about the entire phenomenon of cleansing action of soap. Rubbing of clothes with brush or agitation in washing machine. Next one, classification based on the nature of dispersion medium. Colloidal particles classified on the basis of dispersion medium and type of colloid. When dispersion medium is air, already I told you the colloidal solution is formed. What way? Dispersed phase dP plus dispersion medium is equal to colloidal solution. Colloidal solution. So here the dispersion medium when air, that such kind of solutions are called as aerosols. When dispersion medium is water, such kind of solutions are known as hydrosol or aquasol. When dispersion medium is benzene, it considered as benzosol. The same way when dispersion medium is alcohol, such kind of colloidal solutions are known as alcosols. So on the basis of medium, we can classify the colloidal solutions like this way, which are aerosol, hydrosol, benzosol, alcohol. Final, fifth classification, colloidal particles. Classification based upon nature of the charge. Dispersed phase particles have a charge based on that positively sol and negative sol. Already once again I am going to tell you, dispersed phase dP plus dispersion medium dm, you will get a colloidal solution. Colloidal solution. So when dP is positive charge, dispersed phase is positive charge, such kind of solution is positive colloidal solution. When dP is existing in negative charge, such kind of solutions are comes under negative colloidal solutions. See one by one. Positive sol or positive colloidal solution, it means the dispersed phase particles carries positive charge. Negative sol or negative colloidal solution means dispersed phase particle carries negative charge. Examples for positive colloidal solutions and negative colloidal solutions, where the dispersed phase is positive charge in positive sols, dispersed phase particles exhibit negative charge in negative sol. See here, hydrated metallic oxides, example Al2O, H2O, chromic oxide, XH2O, Fe2O3, XH2O. For coming to the negative charged salts, metals, example copper, silver, gold salts. And basic dyes, stuffs, example methylene blue sol. Metallic sulfides, example arsenic oxide H2O3, antimony sulfide is B2S3, cadmium sulfide, salts. Salts means in water. Hemoglobin, it means blood, where it's acting as a positively charged sol. Acid dyes are stuffs, example for eosin or Congo red salts, which are example for negatively charged salts. Oxides of titanium, TiO2 salt is also an example of positively charged salt. Salts of starch, gum, gelatin, clay, charcoal will come under negatively charged salts. So these are the many examples I have given in the aspect of IIT-JEE and NEET. So these are the example for positive salts and negative salts. But CBSE point of view, just you know for definition, and at least you have to give 2 or 3 examples. So finally, the classification of colloidal solutions are over. I am going to give you small review and classification. Firstly, all colloidal solutions we classified on the basis of state. Solid, 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 liquid, solid, gas, gas and gas, like that. Secondly, all the colloidal solutions we classified with respect to affinity, which are lyophilic, lyeophobic. Lyophilic colloids and lyeophobic colloids. After that, all colloidal solutions we classified with respect of association. Third one is associated colloid, that is missile. And fourth category, now only we have finished. Fourth one, based upon the nature of the dispersion medium. Dispersion medium, what we are using. When you use air, that is aerosol. When you use alcohol, alkosol. Benzene, benzosol, like that. Finally, fifth classification based upon dispersed phase charge. What? Two we have. One is positively charged salts and negatively charged salts. This is about the classification of colloidal solutions. Now, we are entering into the part 4, colloidal solutions, which comes under surface chemistry. We'll see what are the topics comes under this part 4. Preparation of colloids, purification of colloidal solutions, and properties. These three topics comes under part 4. Part 3 and part 4 completely exclusively for belong to colloids topic only. In part 3 what we have studied? Types of colloids. Especially we studied about types of colloids and characteristic properties of colloids. And part 4 we are going to learn preparation, purification, properties. We'll see one by one. In properties, these are the main properties. We are going to learn it, which are number 1 is colligative properties. Colloidal particles exhibit colligative properties. Colloidal particles exhibit Tyndall effect. Colloidal particles, due to the presence of colloidal particles, the solution is getting color. Due to the presence of colloidal particles, the solution is, we can observe the Brownian movement. And few colloidal particles gets charge and electrophoresis. These are the points, properties we are going to learn in this part 4. Preparation, purification, properties. Preparation. So lyophilic salts, lyophilic colloidal solutions preparation. Starch solution, example. Gum solution, colloidal solution is example. Egg albumin colloidal solution. Egg albumin colloidal solution. When lyeophobic salts, three examples we have: ferric hydroxide colloidal solution preparation, aluminium hydroxide colloidal solution preparation, and arsenous sulfide colloidal solution preparation. These three total 6 colloidal preparations is there in our practicals also. In our chemistry lab, we have to prepare all these 6 colloidal solutions. In what way we are going to prepare? Philic means what I told you, my dear students. Dispersed phase and dispersion medium, the affinity, the interaction is high. Lyeophobic means dispersed phase particles and dispersion medium, the interaction is very poor. So we are going to see. Next, in purification, 4 techniques we have. One is dialysis, electrodialysis, ultrafiltration. Coming to the properties, once again I am telling you, colligative, Tyndall effect, color formation, Brownian movement, and charge, electrophoresis. These are the topics. We will see one by one. Number 1, preparation of lyophilic salts. Example, starch, gum, and egg albumin. Preparation of starch solution. And lyeophobic salts, as per IIT-JEE and NEET, we have some more methods. I am going to explain you. Lyeophobic salts can also be prepared by the following methods. Number 1 is condensation method, dispersion method. Condensation method have 2 techniques. One is chemical method and physical method. And dispersion method are Bragg's arc method and bipeptidization method. All these 4 methods are used to prepare a lyeophobic salts. Liophobic salts. We'll see one by one. First one, preparation of colloidal solutions, that is liophobic salts. Example, starch solution. You know very well about starch powder. Starch forms liophobic salt when water is used as a dispersion medium. So, starch powder, when dissolved in water, you will get a starch solution, where water is known as dispersion medium. The formation of salt is accelerated by heating. It will not form simply when you add starch into the water, you won't get a colloidal solution. When your starch powder is added to water after shaking well, then you have to heat it by heating. Starch salt can be prepared by heating it and water at 100 degrees centigrade. It is quite stable and is not affected by the presence of any electrolytic impurity. So this is about the preparation of starch salt. What way we are going to do is, see here. For example, first you have to take one beaker, pour some water, heat this water up to 100 degrees centigrade. Then you have to add a little amount of starch powder. While adding, you have to mix vigorously. After some time, the entire starch particles will be mixed up with water. This solution is known as starch colloidal solution. Starch is dispersed phase and water is dispersion medium. Dispersed phase dP and dispersion medium, this attraction is very strong. So hence this solution is known as liophobic solution. That only I have written in this. Starch forms liophobic solution when water is used as a dispersion medium. The formation of salt is accelerated by heating. Starch salt can be prepared by heating it and water at 100 degrees centigrade. It is quite stable and is not affected by the presence of any electrolyte impurity. So after formation of the starch solution, it will not be affected. The impurity, when you add a little bit of any other, this is the starch solution. When you add any impurity, the colloidal solution will not disturb. Next, gum solution. It is also an example for liophobic. So by using of gum, we can prepare the water. Very simple. Like starch, gum also form liophobic salt with water. Instead of boiling water, warm water is used to form the preparation of salt because gum is quite soluble in warm water. So warm water you have to take. In that warm water, what you want to add? A little quantity of gum is add and mix it. You will get a colloidal solution where water is dispersion medium, gum particles are dispersed phase. So such kind of solution is also liophobic solution. Egg albumin salt. Everyone knows about egg. Egg have two colors inside, white and as well as yellow. Egg albumin, which is obtained from the egg from liophobic salt with cold water. The salt is quite stable and is not affected by the presence of trace of impurity. It is also not affected when you add any impurity. Egg albumin means not yellow, the white. The white you have to collect from the egg and which is placed into the water. Here the water, cool water, no issue of taking heating 100 degrees centigrade or warm water. In cool water, this egg albumin will be dissolved and after that you will get a colloidal solution, that is egg albumin colloidal solution, where egg albumin is dispersed phase, water is dispersion medium. This is about the preparation of liophobic salts. Example, starch, gum and egg albumin solution. Next, preparation of leophobic solutions. Example is ferric hydroxide, FeOH taken 3 is ferric hydroxide. Name itself, what is dispersed phase you can expect. Yes. Ferric hydroxide forms leophobic salts on treatment with water. Ferric hydroxide salt is prepared by the hydrolysis of ferric chloride with the boiling distilled water. Then the reaction takes place as follows. What we are taking here? Ferric chloride, FeCl3, when reacts with H2O. H2O means what, ma? HOH. How many molecules we are taking? 3 water molecules, means 3 HOH. So iron valency is plus 3, Fe plus 3. And here 3 Cl minus ions. When reacts, what will happen? This Fe is attacking 3 OH minus ions. One here and another one and also another one. These 3 OH minus ions combine with that, you will get a FeOH taken 3. Ferric hydroxide plus, here 3 chloride ions are there, 3 Cl minus and 3 hydrogens will be left. You will get a 3 HCl. So this is the chemical reaction. So ferric chloride reacts with water, you will get a red solution, that is red salt, that is known as ferric hydroxide. This salt is comes under leophobic salt. Ferric hydroxide powder directly we are not taking. What we are taking to prepare ferric hydroxide? Ferric chloride. Ferric chloride when dissolved in water, this is dispersion medium. This is dispersed phase. But finally what salt you are getting? What colloidal solution you are getting? Red salt. Red color, that formula is ferric hydroxide. Next, the hydrolysis reaction produces insoluble ferric hydroxide precipitates or particles which undergo agglomerization to yield bigger particles of colloidal dimensions. These particles absorb ferric ions, preferentially form the solution to give positively charge to the salt particles. Stability of salt is due to the charge on the salt particles. Hydrochloric acid produced during hydrolysis must be removed from the salt because it destabilizes the salt. HCl can be removed from the salt by dialysis process, otherwise salt will not be stable. See here, while you are adding ferric chloride and water, we are getting the salt, that is leophobic salt, ferric hydroxide. Along with that, we are getting one more liquid. It is a mixture we are getting. What is that? Hydrochloric aqueous. This hydrochloric aqueous you have to remove from this solution. When you won't remove, again the hydrochloric acid reacts with this and this colloidal solution will not be stabilized. That is the meaning of entire this paragraph. What is that? Here hydrochloric acid produced during the hydrolysis must be removed from the salt because it destabilizes the salt. HCl can be removed from the salt by dialysis process. We have a purification techniques are there, next topic. Through the dialysis, we can remove this hydrochloric acid. So this is about the preparation of leophobic salt, that is ferric hydroxide. Ferric hydroxide. Next one. Aluminium hydroxide salt or aluminium hydroxide colloidal solution preparation. It is also hydrophobic in nature and is obtained by the hydrolysis of aluminium chloride. Same way, aluminium hydroxide is obtaining by treatment with aluminium chloride plus water. See the equation. Aluminium chloride plus water We are getting aluminium hydroxide along with that hydrochloric acid aqueous. Hydrochloric acid produced during the hydrolysis is removed by the dialysis because aluminium hydroxide salt is affected by the presence of ionic impurities. So we have to remove this hydrochloric acid. And third leophobic salt is arsenic chloride. It is a leophobic salt obtained by the hydrolysis of arsenous oxide with boiling distilled water followed by passing H2S gas through it. Arsenous sulfide is the third example. This arsenous sulfide is this one, As2S3. As2S3, this yellow, As2S3, this salt is yellow in color. Arsenous sulfide. Arsenous sulfide, where arsenous valency is +3. We know that sulfide valence is -2. You will get the formula As2S3, arsenous sulfide. This we are going to prepare. How it will prepare? By two steps. Step 1. First we are taking arsenous oxide. Arsenous oxide undergoes hydrolysis or placed into the water. That arsenous oxide is changed into arsenous hydroxide, ASOH taken 3. This arsenous hydroxide is in what state? It is in solid state. That is called as a precipitate. So it is leophobic salt obtained by the hydrolysis of arsenous oxide with boiling distilled water followed by passing H2S gas through it. So we are getting arsenous hydroxide, and after that what we have to do? We have to pass the H2S gas. What way? I am going to show you. For example, this is a test tube or your beaker. First what I am taking? As2O3. It is in powder manner. This is I am taking into this test tube or beaker. Now I have to add water. So now water added. So water plus As2O3, the chemical reaction is going on. After that you will get ASOH taken 3, arsenous hydroxide. This arsenous hydroxide, after that, this is in the closed manner, only small hole is there. Through this you have to send H2S gas, hydrogen sulfide gas. When hydrogen sulfide gas is passed through, this H2S reacts with ASOH taken 3, you will get a As2S3, arsenous sulfide colloidal solution. This is about the preparation of third leophobic solution. Preparation of leophobic salts in different method as per IIT-JEE NEET method. See here, one is condensation method, another one is dispersion methods. Under the condensation method, the leophobic salts we can manufacture by chemical methods and physical methods. In dispersion method, Brax and bipeptidization method. Preparation of leophobic salts, condensation method, we'll see. The method employed are condensation methods and dispersion methods. Under this chemical method, so chemical reaction, now only we have seen arsenous oxide reacts with H2S, you are getting As2S3 is the salt. Oxidation, H2S plus SO2, H2O3. AgNO3 plus tannic acid, you are getting Ag salt. These are all the examples for chemical method. Chemical means chemical reaction. One substance is chemically reacts with another substance, you are getting a liquid. So this is called as a colloidal solution. In chemical method, while simply adding As2O3 into water, this will not be dissolved. Hence you go for chemical method. So because the interaction between these two is less, to improve the interaction, it will undergo chemical reaction. So in this way, double decomposition method, it means replaces the places. Here H2S is there. In H2 place, S place what is coming? O is coming. In O place, what is going? S is going. That is called a double displacement. Oxidation, adding of oxygen. Sulfur is removed, oxygen is adding. And reduction, removal of oxygen. So AgNO3, where oxygen is removed in the form of nitrate, you are getting Ag sal. The same way hydrolysis, ferric chloride undergoes hydrolysis, we are getting ferric hydroxide. Physical methods, change of solvent. When the ethanolic solution of sulfur is added to an excess of water, sulfur sol is obtained. What I am saying? Change of solvent. Already ethanolic solution is there. Ethanolic solution means this is water. Ethanol is added. Here, instead of ethanolic solution, what we are doing? When ethanolic solution of sulfur is added to an excess of water, you are getting a sulfur salt. First we have ethanolic solution. Ethanolic means this is ethanol, ethyl alcohol, ethanol plus sulfur. Ethanol is what? It is the solvent or dispersion medium. So when you add more water, water quantity I am increasing, so that this ethanolic solution, the ethanol percentage will be decreases, water percentage I am increasing, then ethanolic solution is changed into sulfur, aqua sulfur, water with sulfur. So that is a physical method. Sulfur salt, sulfur colloidal solution, sulfur plus water colloidal solution we are preparing by changing the solvent. By changing the solvent, simply adding water, ethanol is diluted and water concentration will be increases. Next two more methods, dispersion method, Bragg's equation. An arc is struck between two metals electrodes of silver, gold, platinum, held at the surface of cold water containing trace of alkali with soil of material is obtained. So this is Bragg's, not breeding. This is Bragg's. Bragg's. Okay. So here in this method what we are doing, an arc is struck between two metal electrodes. For example, this is one metal. Electrode means we can use, current is passed through this. This is silver. Both are silver. Both are silver electrodes. Between gold or platinum held at the surface of the cold water. Okay. Cold water, you will take one container. So this is the water, cold water. On the surface what I am keeping? Two electrodes I am keeping. Containing cold water, containing trace of alkali when salt material is obtained. When electric current is passed through this, in the presence of alkali means sodium hydroxide or potassium hydroxide, a little quantity you have to add it. Then you will get a what? When silver is used as electrode, silver salt will be formed, silver colloidal solution will be formed. When gold is used as an electrode here, gold solution will be formed. So that gold particles will dissolve in the water. Here when you use silver, silver particles will be dispersed in the water. So this gold salt and silver salt is an example for Bragg's preparation. Bipeptidization method is the last one. The process of converting a precipitate into colloidal salt by shaking it with dispersion medium in the presence of small amount of electrolyte. So what is the meaning of this? The process of converting precipitate. Precipitate means solid. This is the water. In the bottom we have some solid particles are there, that is called precipitate, PPT. This precipitate, converting the precipitate into colloidal solution. Precipitate is smallly divided and mixed up with the entire whole water. Then you can't see the precipitate. This precipitate is distributed uniformly into this water. So this is called as colloidal solution. So the process of converting of precipitate into colloidal salt by shaking it, you have to shake it with dispersion medium. Medium is water in the presence of small amount of electrolyte. Any sodium chloride, electrolyte means it's a conductor, Nana. Any salt. When you add a small little bit of electrolyte, this entire precipitate is mixed up with water to form a colloidal solution. This method is bipeptidization method. Here the electrolyte, what electrolyte we are using, based on that different exams will come. The electrolyte used for this purpose is called the peptizing agent. So precipitates ferric hydroxide is there. Precipitate means what I told you, which is in the bottom. This is water which is in the bottom. For example, ferric hydroxide is there in the bottom, right? So you have to mix. While mixing, what you want to do, shaking it with dispersion medium, water, shaking with this dispersion medium. By adding peptizing agent or electrolyte, here what electrolyte we are adding, ferric chloride electrolyte is adding. Then this ferric hydroxide salt you are getting, that will be completely mixed up with water uniformly. Same way, AgCl, where the peptizing agent is HCl, you will get a AgCl salt. And instead of HCl, AgCl electrolyte, little you add, you will get same AgCl positive salt. And cadmium sulfide, where the peptizing agent is H2S. So this is about the peptizing method. Third one, the cellulose nitrate is peptized by the mixture of ethanol and water. Cellulose nitrate is one of the colloidal solution. The cellulose nitrate is formed by the peptizing by the mixture of ethanol and water. Ethanol and water is used as a peptizing agent like this. The product obtained is called as colloidon. Now purification of solutions, next topic. Generally, colloidal solutions associated with excessive amount of electrolyte and some other soluble substances which acts as impurities. After preparing colloidal solutions, we have still some impurities are there, that those impurities means electrolytes and other impurities. So how we can purify that? Few important methods are there. Number one is dialysis, the process of removal of dissolved substances from colloidal solution by means of diffusion through a suitable membrane is called as dialysis. So see here, my dear student, dialysis means the process of removal of dissolved substances, impurities, from colloidal solution by means of diffusion through a suitable membrane. For example, this is one colloidal solution. In this colloidal solution, we have some impurities. We have some impurities. Okay, we have some impurities. These impurities I want to remove it. While removing, what I am doing is, this solution is connected with one more tank. In this tank, I am going to arrange one filter. What filter I am arranging here? This is allows only ions, not molecules. It allows only ions. Electrolyte is the impurity. This is the electrolyte. Electrolyte means it is ionized. It means this filter can allows only ions, not colloidal, the red color colloidal particles it won't allow. So when this liquid is flow into this filter, what will happen? All blue will be coming into this filter and you will get all impurities in this container. So this is called as dialysis. Whatever the impurities are there, which will absorbed by this filter. One membrane. This is called as a membrane. One wall. The process of removal of dissolved substances, impurities, from colloidal solution by means of diffusion. Diffusion means moving from one place to another place through one filter. Diffusion through a suitable membrane is called as dialysis. This is called membrane. Next, electrodialysis. If dialysis is carried out in the presence of electric field is called electrodialysis. Dialysis carried out in the presence of electric field. So the colloidal particles are diffusing, moving In the presence of current, such kind of dialysis is called as what? Electrodialysis. Ultrafiltration. The process of separating of the colloidal particles from the solvent and soluble solutes present in the colloidal solution by specially prepared filters, that is called ultrafilter, known as ultrafiltration. In these three, technique is same. In dialysis, one suitable membrane we are arranging. Here also same membrane is there, but in the presence of electric current. Here we are arranging ultrafiltrate membrane we are going to change in this case. In all three cases, what allows that filter? It allows only ionized electrolytes and not the colloidal particles. Through this way, the pure colloidal solution will get it. This is about the purification of colloidal solution. And one more topic is left, that is properties of colloidal solutions, that we will see tomorrow morning class. So thank you students. I am going to stop at this here. All these